Hi there. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. It's good to have your company. Coming up on this episode, we are going to be looking at the latest launch from Blue Origin. It's been a while. They've had some technical issues, but they've now had a successful launch and some interesting side stories in this one as well. We're going to look at a planet that's, not made of, but has the consistency of fairy floss. That's what we call it in Australia. You might call it cotton candy or candy floss, depending on where you're from. And gravitational wave background in the universe, more evidence of that. I guess you could compare it to what we refer to as cosmic microwave background radiation, but this is in gravitational wave form. I think I got that right. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And once again, here to grace us with his presence is Professor Fred Watson, astronomer at large. You got some fairy floss on your face.
Oh, sorry about that. Yeah. Yes. I must have a shave.
Could be a moustache. Have you dyed it pink or something?
No, actually, eating fairy floss is lethal with a moustache, and it's
it is.
Yeah. The other thing that's really hard to do is scones with jam and cream on, because you end up cream everywhere.
Yes, yeah, I remember my days of being a bearded fellow, and there were some things you just didn't even attempt to eat.
No, that's right.
Especially if you get like sauce or ketchup in it, and you don't know, and it dries out, and then it's horrible.
Yeah,
it's disgusting, actually. We've got a lot to talk about, Fred, and I did want to sort of bring up a topic without notice, but I don't know if you saw the story over the weekend of the bright flash in the sky that was seen in Europe, Spain and Portugal.
Yeah.
What fascinated me about this story is it turned out to be a piece of Comet after they did a bit of an analysis. Now, how do they know that compared to it being a meteor or a meteorite?
Yeah, so I'd looked at that story as well. It was seen over Portugal and other European countries. Very, very bright. Something like 44 kilometers per second fly-through speed. I checked all that. So because there was so much imagery of it, Andrew, you can essentially trace back its orbit, the orbit that it was on when it collided with the Earth's atmosphere. And it's that gives you the clue as to where it comes from. I assume, I don't know, I didn't follow up on the story. I did see that people were quoting that it might be a broken off bit of comet. If you've got a very elongated orbit, one that, will be typical of what a comet might look like, that would be a clue to that.
Would the colour be a factor? Because
yes, that's correct.
There can be different colours depending on their composition, can't they?
That's right. That's correct. And yes, indeed. I think it was magnesium that was quite strong in the colouring, or hypothesised to be quite strong in the colouring in terms of the material that was contained there. And I think magnesium was another pointer to it being of cometary rather than asteroidal origin. Most meteors are just dust, leftover debris from the formation of the solar system. So they're more related to asteroids than comets, but this might be quite an unusual one.
Indeed. Some of the footage was extraordinary. I remember one particular video I saw of a young woman who was being filmed, I assume, by her boyfriend, and she was just talking. I think she was in Portugal, and the sky just lit up bright green, and she just looked up. Yeah. There was sort of this silence for a while. It's just a beautiful piece of video.
I should check that out. I haven't seen that one.
Got an amazing shot of it, just streaking over her head, basically, and then disappearing beyond the horizon. But it just turned night into day very briefly. A Green Day, which is also a great band, but it was quite extraordinary. Worth looking up. There's plenty of footage of it. Lots of people saw it. Yeah. Now, going from green to blue now, Fred, did you like that segue?
It's pretty good. Yeah, you should be broadcasting.
Yes, well, I think I'm just about to retire. Now, Blue Origin has been back up for the first time in a couple of years. They've had some setbacks, but this is actually, I suppose, not only a great return to space for them, but a couple of, well, at least one major record set in the process.
Yeah, and a really nice story too. So this is Blue Origin's NS-25 mission. Again, as these flights are, a suborbital flight, and you're quite right, they had issues with an uncrewed flight a couple of years ago, which grounded them for a while. But they're back in business now. The flight was uneventful. I think one of the return parachutes was not fully opened when they landed, but Blue Origin can land with only 2 parachutes. It usually has 3. And I think they'll clearly be looking at all that. But the thing that you alluded to, a fabulous story. A gentleman by the name of Ed Dwight, who is, I think I'm right in saying, 90 years old.
Yes.
He was selected back in 1961 by the president, John F. Kennedy, as an astronaut candidate to train at the U.S. Air Force's Aerospace Research Pilot School, as it then was, a conduit basically into the astronaut corps at the time. NASA was very young then. NASA was only formed in 1958. So, what it meant was that he was the first astronaut candidate of color. And so that would have, been a record-breaking status for him if he'd been the first astronaut of color to fly. He actually wasn't selected, though. So he completed his training. He was recommended by the Air Force for the astronaut corps, but he wasn't selected. In those days, it was the luck of the draw. There were many people available. I think there was a cohort of female astronauts that never got selected either in the very early days. But this time he made it. So he flew into space with the Blue Origin New Shepard mission, NS-25. A lovely quote from him. I thought I didn't need this in my life, but I lied. I really did need it. It was the first real deal that I got involved with that I wasn't successful at. He added, referring to his non-selection by NASA. This is, I'm quoting here on space.com. So he said, I wish I'd gotten it then, but it's great. That's all I can say. Good on him. Good on you, Ed. And what a wonderful thing to happen.
Yeah, Holly, he got into space at the age of 90 years, 8 months and 10 days,
That's right,
which is the oldest person ever to go into space, which is extraordinary. In terms of his early selection for potential astronaut candidacy, that it was the subject of a lot of controversy at the time because, as you said, he didn't get selected. He was quoted in 1966 as saying that racial politics had forced him out of NASA and into the regular officer corps. So it doesn't sound like he had a smooth run in the situation that he faced, and probably was a bit resentful by the sound of it. But he went on. This is what I found amazing. He went on to work as an engineer and then into real estate, but he became a sculptor.
Yes.
Which I find amazing. He's I'm not aware of his work, but he's done some amazing sculptures apparently. He was commissioned by the Colorado Centennial Commission to create a series of bronze sculptures entitled Black Frontier in the American West. So he must have been a talented guy.
Yeah,
well, he's still alive. I'm not, he's obviously a talented guy and has had quite an extraordinary career, not involving space by the sound of it, but he finally got there, which is fantastic.
Yeah,
what a brilliant thing.
Yeah, it's a really nice story. And just to mention, he was one of 6 passengers on board NS-25, and I think they all had a great time.
Yes, and I think he also was, in 2020, inducted into, now what was it? I can't remember, but he was recognised for his candidacy.
Astronaut Hall of Fame? I can't remember.
Something like that, yeah. It's probably right in front of me and I cannot see it. Don't you hate that?
Yes, I do. Happens to me all the time on Space Nuts.
Yeah. Never mind. But yeah, a great achievement by him, and of course Blue Origin back in action after a couple of years off. Fred, let's keep moving. We're going through lickety-split today, but this one I particularly, this caught my attention on the weekend. I'm glad you picked up on it to talk about. This is a newly discovered planet or newly identified planet. I don't know which way you go, because sometimes they find these things and you don't hear about them for years. But this is a gas giant. It's huge, but it's also not very dense. It's got sort of opposing factors that come into play here, and it's being described as a cotton candy or candy floss or fairy floss planet. Let's talk about this. It's one of the WASP discoveries.
That's correct. It is. It is WASP 13. Where is it? I've lost the number now. 193b. WASP 193b. WASP, if I remember rightly, stands for Wide Angle Search for Planets. It's actually an old colleague of mine who started that program back in the day. Somebody I worked with in the 1990s at the Royal Greenwich Observatory. So great program, and has done very well. It's a program that looks for planets by the occultation method. That means as the planet passes in front of its parent star, the light of the parent star dims slightly. And you recognize the dimming as being due to the obscuration by a planet, and then it goes around its orbit and comes back and does it again. And when it does it again, then you know you've got a planet, and you can work out its orbital characteristics and things of that sort. But what you need to do for more details is to look at the spectrum of the object, in particular the spectrum of the star, to do what we call the Doppler wobble technique, where you look at the wobble in the star's motion, which is detected. This is its motion along the line of sight, what we call the radial velocity. That can be detected. Wobble caused by the planet pulling the star slightly out of place as it goes around. That basically essentially resulted in scientists knowing the mass of WASP 193b, and it turns out that it's paradoxical. It is paradoxical, as the headline in SciTech Daily says: a baffling cosmic mystery, a giant planet as fluffy as cotton candy. And so what we have here is a planet about 1,200 light years away. It's 50% bigger in diameter than Jupiter, but only 1/7 of the mass. And that means its density is very low. There's a dog barking outside. Probably means...
It's the dog star, Fred.
Yeah, the dog. Oh, that could be it, yes. Well, the dog star is called Geordie, and he barks any time a leaf moves outside or anything like that. It's very sensitive. I think his mummy's probably just come back. That's probably what it is. Anyway, so the statistics themselves are quite interesting. It's got a density, and I'm working in the old units here of grams per cubic centimetre. Remember, water has a density of 1 gram per cubic centimetre. Our rocky Earth has a higher density, 5.51 grams per cubic centimetre. Jupiter, being a gas giant, is lower in density on average. It probably has a rocky core. We don't really know too much about the core of Jupiter, but it's 1.33 grams per cubic centimetre. So that's the density of Jupiter. And then we move to WASP 193b, and its density is 0.059 grams per cubic centimetre, which is about the same as cotton candy. It's about the same. Now, cotton candy's light, or candy floss, or fairy floss, because it's mostly air. It's essentially an open structure which has air in it. Now, clearly, WASP 193b doesn't have air because it's in space, but it may well have some sort of structure that is similar to cotton candy. We really don't know. It's the reason why it's hitting the headlines is that the scientists who have made this discovery they're mostly in the US. MIT, Massachusetts Institute of Technology, is one of the institutions. The question now is, how did planets get like this? How can you form a planet that's like that? Sorry,
that's the question I actually wrote down on my piece of paper. How does a planet become so fluffy, for want of a better term? And what could it possibly be made of?
Exactly. So there's a few comments from some of the researchers. One, some of whom are in Spain, by the way. I did mention MIT, but let me just quote from some of the authors. Or quotes from some of the authors. Here's one. The planet is so light that it's difficult to think of an analog, solid-state material. The reason why it's close to cotton candy is because both are pretty much air. The planet is basically super fluffy. And then from one of the Spanish collaborators on this, we don't know where to put this planet in all the formation theories we have right now, because it's an outlier of all of them. We cannot explain how this planet was formed. Looking more closely at its atmosphere will allow us to constrain an evolutionary path of this planet. In other words, looking at how something like this might have come about. If you can see odd chemicals in its atmosphere or something of that sort. And then just one other quote, WASP 193b is a cosmic mystery. Solving it will require some more observational and theoretical work, notably to measure its atmospheric properties with the James Webb Space Telescope and to confront them to different theoretical mechanisms that could possibly result in such an extreme inflation. It's inflated. That's the way it's kind of puffed out. And what causes that? Is there an energy source in it that's blowing stuff outwards? I don't know. I don't know the answer to that.
Yeah, it makes you wonder why you'd call it a planet if it's just inconsistent. It's just a
what else are you going to call it?
I don't know. It's
a blob.
A blob. Yeah, that's more.
Yes.
That would seem more consistent with its makeup,
with its nature, and yet its characteristics are very much those of a planet. It's in orbit around a star. It's quite a short orbit, if I remember. It's just a few days. So, and I think it's probably a red dwarf. I can't remember the star itself, the characteristic of its.
I think they said it was actually a sun-like star. Okay. And the orbit is 6 1/4 days.
It's 6 1/4 days. That's correct. Yes.
Yeah, how's that for a memory? I only read that a minute ago.
Yeah. I've got it in front of me, which is even better. Yeah.
But it is a mystery, and this is like we don't know so much about Jupiter and Saturn and the ice giants further out, but here's one that's 1,200 odd light years away that we've discovered that it's just so very different to what we think of in terms of gas giants.
Yeah.
And is it possible it was just made up of leftover stuff and there wasn't much left? And it's
yeah, but the trouble is, that's how planets form anyway. It's leftover stuff.
Yeah.
And so there must be something else going on. I think this is one we should keep an eye on, though, Andrew. So there'll no doubt be more research coming out about it.
Is it actually pink? Do we know what color it is?
We don't actually, because we don't know, and that's because all we can see at the moment is the obscuration of the planet. Of the star by the planet, and the radial velocity changes in the star itself. So that's not much information to tell you what color it is. But if the James Webb Telescope gets onto it, there's every likelihood that when the planet passes in front of its parent star, some of that light from the parent star goes through the atmosphere of the planet, and you can actually detect from that what the constituents of the atmosphere are, and that might tell us, first of all, what it's made of, what the atmosphere is made of, why it's so different from all the others, and whether it has a color, whether it's pink or blue.
Yeah. It's probably yellow or reddish in color, I would imagine, but who knows? I mean, two of ours are blue. Well, no, one's blue, one's green.
Yeah, they're both actually. They're both looking more similar colours now. There's been some work done on this, which I saw recently, that the difference in colouring has kind of been exaggerated over the years.
Right. Yeah, now that you mentioned that, I do remember reading about it, and they were basically saying the similarities between Neptune and Uranus are quite extraordinary.
Yes.
They're almost identical twins.
Yeah. Yeah.
Yes. But keep an eye out for this one. This is just if you want to try and spy it in the night sky, it's right next to the big Ferris wheel, so it shouldn't be hard to find.
But just watch out for the cosmic roller coaster, which is probably in the way as well. Yeah.
And there's terrible show bags full of junk. They're terrible too.
Maybe that's what it is. Maybe it's made of show bags.
Remnant show bags.
Yes.
No, great story though, and well worth looking into. And you can find that on SciTech Daily. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts. Now, Fred, to one of the most popular topics on Space Nuts, and certainly one that draws a lot of questions from the audience, and that is gravitational waves. What we are talking about today is not quite that. This is some work that's being done on background gravitational waves. Now, I said at the beginning that this was, I would describe this like the cosmic microwave background radiation, the remnants of the Big Bang. Well, this is the remnants of gravitational wave activity, and they're calling it gravitational wave background in the universe. Am I right, or have I just completely decimated this entire story?
You're right-ish.
Right-ish is good enough for me.
Yeah, in that the gravitational wave background is called the background because it's in the background of everything the cosmic microwave background is in the background of everything we can see. It's the flash of the Big Bang. It's something that originated in the Big Bang. And so it provides a backdrop to all our observations. It's there in the background. If you've got the microwave telescopes, you can see it, and indeed you can map it. We have the best map we have today of the microwave background comes from the Planck spacecraft, a European spacecraft that mapped it in great detail. And it's because of that mapping that we can, that we can see structure in the cosmic microwave background radiation that tells us about conditions in the Big Bang. The background that we're talking about here is slightly different. Whilst it is true that the Big Bang would have caused gravitational waves, there is something else going on that's sort of spread throughout the whole universe, and that is a background of, you could call it interference. It's a little bit like, if you're broadcasting, as you often do, and your listeners are hearing you over the airwaves, there might be a bit of a background hiss or something that comes from interference. And that, I think that's the way in which this term is being used for this, because what has been detected, and the evidence that the headline with this story was that the evidence is growing for this, is a sort of background hiss, if I can put it that way, of gravitational waves that come from many phenomena going on in space, mostly mergers, mostly neutron star black hole collisions, or black hole collisions, or neutron star collisions, all that sort of constantly going on, which gives you a background level of gravitational radiation, so the gravitational waves sloshing around through the whole universe that can't be pinned down to come from a specific source, which is what the LIGO detector does, and it's comparable instruments throughout the world. LIGO, Large Interferometric Gravitational Wave Observatory, picks up signals, the ripples in space that come from identifiable phenomena. But there is also a kind of background swill or swell of gravitational waves which are detectable in a different way. And that's why this story is an interesting one that does include Australian science as well. So it turns out that binary pulsars, which are essentially the I beg your pardon, there are some binary pulsars involved with this, but pulsars. Let me just explain what pulsars are. Pulsating radio sources, they basically are. They're rapidly rotating neutron stars, which are beaming out radiation in a lighthouse-like fashion. And essentially the beams of radiation, they're radio waves principally, sometimes they're seen invisible, optical pulsars. They if they flash across the direction of Earth, then we see a pulse. And it turns out that rotation of those neutron stars is very, very constant. It's a constant, almost better than atomic clocks. They are timing devices better than our best atomic clocks. They're so regular. But because they're part of the fabric of space, they're sort of being moved around by gravitational waves. And that changes the frequency of the pulsation. And so if you can set up what are called pulsar timing networks or pulsar timing arrays, then, and if you can do that from many places on Earth, so you're kind of effectively looking in different directions at different pulsars, you can see the effect of gravitational waves. And so the timing arrays that are mentioned in this paper, European Pulsar Timing Array, the Indian Pulsar Timing Array, the North American Nanohertz Observatory, and the Parkes Pulsar Timing Array. These are basically arrays that are looking at the timing of these pulsars and measuring how they're changing slightly due to this groundswell of gravitational waves that's sort of bucketing through the universe in general. And is thought to come from it's superimposed gravitational waves from lots and lots of things going on in the universe. Black hole binaries orbiting one another. Collisions, they are more specific events, but the smaller ones at great distances would contribute to this background.
So what we're talking about, just to clear it in my head, you've got a pond, you chuck in 100 pebbles, and all the waves just crisscross and crisscross backwards and forwards constantly. That's the gravitational wave background.
Absolutely, the analog equivalent, and very nicely put, if I may say so, Andrew. That's exactly right. If you've got this,
you've got to dumb it down for me.
Well, no, that's not dumbing it down. I think that's a very good analog, but you get what I'm meaning. It is a sort of background, and then if somebody throws a rock in, there's a big spreading out of ripples, which you can then detect with a gravitational wave detector. But you've still got this unevenness in the surface of the water. So yeah, great analog.
Wow. Okay. I'm sure we'll get a lot of questions about this, but I'd never thought of gravitational waves as being just bouncing around constantly and interrupting things that we can observe, so that we can piece together what's happening to a certain degree. But I'm sure we'll get questions about it, Fred. Absolutely.
That'll be good.
People are fascinated by these kinds of things. And I think it's because of the mystery that surrounds them that gets people wondering and coming up with their own ideas. And I love that. I love it when people come up with their own ideas of what might be happening, because that's how you figure things out in the end.
It is indeed. That's right.
Oh, and you mentioned that background hiss when I'm on the radio. That's just too many eggs for breakfast, I must say. So, yeah, can't do much about that.
Yeah. Well, that's right. You should move your mic away from your digestive processes. That's something I've always found as a.
I've got to tell you though, I was on air once, and I did feel a sort of movement, and I thought I'll just quietly. Didn't quite, and it actually happened between words. So. It wasn't, and it wasn't a hit. Yeah, great moments in radio.
Yeah, well, quite so, yes. We should find the tape of that somewhere, shouldn't we?
I'm pretty sure it's long gone.
Yes,
long gone. Thank goodness. Thank goodness. Too many other embarrassing moments that I've managed to keep, though. Now, if you want to chase up that story about the gravitational wave background, it's on universetoday.com. Fred, that just about wraps it up for us for another week. Thank you so much.
It's a pleasure, and I hope we'll do it again sometime soon.
Possibly so, maybe in a few minutes. You never know. Time is relative.
It is. It's all relative. That's right. Yeah.
Thanks, Fred. We'll catch you soon. Fred Watson, astronomer at large, and Hugh isn't with us today, so everything went well. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at bytes.com.
This has been another quality podcast production from bytes.com.